Okay, so welcome to the latest in our college entrance exam must-know questions. This time it's on circles and polar graphs. So let's get straight stuck in. Question 1, very gentle starter. Okay, so what is the polar equation of this circle here? Well, we can see here is the centre, and basically no matter what angle of theta we take, the radial distance from the origin is exactly the same. It's 1, 2, 3. Therefore, the equation of this circle is simply r equals 3. Nice, easy starter. Okay, let's move straight on to question number 2. Question number 2. Okay, what's the polar equation of this circle? Okay, well, there's a few clues here. First of all, because the circle is symmetrical about the y-axis, and we know if we look at the sign of sine, are all stations to Crewe here, the sine is positive here and here, and sine is negative here and here. So we know that it's symmetric about the y-axis. So because this circle is symmetric about the y-axis, we know this is equal to r equals something sine theta. And all we need to do now is look at 1, 2, 3. So it's 3 high, and therefore r is equal to 3 sine theta, and that is the equation of our second one. Let's have a look at question 3. They get a bit harder. Okay, question number 3. What is the polar equation of this circle? Okay, now again, if we look at our trig, all stations to Crewe here, we notice that cosine is positive here and here, and it's negative here and here. So the sine of cosine is symmetrical about the x-axis. So as this circle here is symmetrical about the x-axis, we know that it's r equals something cos theta. But because it's the, if you like, wrong side of the y-axis, i.e. it's not this side, it's on the other side, we know that it's minus something, and then all we need to do is just work out what this distance here, and it is basically 1, 2, so we know this one is r equals minus 2 cos theta. And just in case there's a little bit of confusion there, when we put theta equals to 0, well, r will be equal to minus 2 times cos of 0, which is equal to minus 2. So when we look at theta in that direction there, it will be minus 2, i.e. 2 in the exact opposite direction. So that's the answer to question number 3, r equals minus 2 cos theta. Okay, so they're getting a bit harder now. Question number 4, what is the polar equation of this circle? Okay, now there's a trick for working this out. We know that it's clearly not symmetrical about the x and y, but it does go through the origin, and therefore we know that it is of the form r equals a cos theta add b sine theta. And the way we work out what a and b is a is where it crosses the x-axis, and it clearly crosses there, 1, 2, 3, 4, and b is where it crosses the y-axis, which is minus 1, minus 2, minus 3. So we know that the equation of this one is equal to r is 4 cos theta minus 3 sine theta. And we'll come back and see another one of these in a later question. Okay, so that one's question 4. Let's have a look at question 5. Question 5, we're dealing with domains now. So sketch the portion of the curve r equals 3 cos theta from theta only going from 0 to pi over 2. Now this here is the entire curve of 3 cos theta. We know that cos theta is symmetrical about the x-axis, and we know that this distance here will be 3 from the origin, which it is, but we're only looking theta from 0 to pi over 2. So how do we know which bit of it is? Okay, well, when theta is equal to 0, r is equal to 3 times cos of 0, which is equal to 3. And when theta equals pi over 2, r is equal to 3 times cos of pi over 2, which is equal to 0. Which means that we know that basically it starts here and it ends here, but we still don't know whether it's the top half or the bottom half portion. So what we need to do is, let's say, find one point in the middle. Let's say theta equals pi over 4. When theta equals pi over 4, r is 3 cos pi over 4, which is 3 over root 2, which is greater than 0, and therefore we know what pi over 4, this one here, we know r is greater than 0, i.e. we now know that it must be the top half of the circle here, and that is the equation of that is the portion of the curve r equals 3 cos theta for that domain. That is the answer to question number 5. Question number 6, again with domains. This one a little bit harder again. We've got this circle here which is not symmetrical about the x or the y. Let's just check if it's right. This here, we've got 1, 2, 3 on the x and we got 1, 2 on the y. So that is the correct formula, but we only want it for theta going from 0 to pi over 2. And so therefore what we need to do is we need to look when theta is 0, r is equal to 3 cos of 0 add 2 sine of 0, and that equals 3. And when theta is equal to pi over 2, it's r is equal to 3 cos pi over 2 add 2 sine pi over 2, which equals 2. And so therefore we know that it starts here when theta is 0 and it finishes here. And what we need to do is we need to find out, well, does it take this root here or this root here? Well, so let's put in theta equals pi over 4, for example, and that gives us 3 over root 2 add 2 over root 2, which is 5 root 2 over 2, which is greater than 0. So when theta is pi over 4, i.e. this one, we know that the radius is greater than 0, so we know it would be this piece, and therefore we know that the portion of the curve which is between 0 and pi over 2 on theta is this bit here. Okay, so far so good. Now the final question, a little bit more tricky again. Question number 7, sketch the portion of the curve r equals 2 cos theta minus 3 sine theta from pi to 5 pi over 4. Okay, well again, let's just check this is the right curve here using our little trick. Well, this here is 2 along the x-axis, so that's correct. And this is here is minus 3 along the y-axis, so that is correct. Okay, so we need to go from theta equals pi to 5 pi over 4. So when theta is equal to pi, we have r is equal to 2 cos pi minus 3 sine pi, and that equals minus 2. So basically when theta is pi, which is that direction, r is minus 2, which means it goes minus 2 in that direction, i.e. it goes 2 in the opposite direction. So when theta is equal to pi, we are actually at there. That's when theta is equal to pi. And when theta is equal to 5 pi over 4, we have r is equal to 2 cos 5 pi over 4 minus 3 sine 5 pi over 4, which is equal to minus 2 over root 2 minus minus 3 over root 2, which is 1 over root 2, which is positive. So when theta is 5 pi over 4, which is basically here, we know that the radial is positive, and therefore we know that it goes from here to here. That's when theta is pi. That is when theta is equal to 5 pi over 4. And so therefore the portion of that circle is the bit that I've just shaded in black. And they are 7 must-know questions. Well, I hope you found those useful. If you did, please press the little like button and subscribe to the Gresty Academy YouTube channel for many more of these. Okay, thank you.